20th, 1969. Mankind is minutes away from its greatest achievement, but suddenly everything goes wrong. A yellow master alarm lights up the cockpit. Code 1202. Neil Armstrong has never seen it before. "Give us a reading on the 1202 program alarm," he says calmly into the radio. His voice is steady, but the fuel counter is ticking down. 20 minutes of oxygen, maybe less. On Earth, 240,000 miles away, Mission Control holds its breath. For the first time, they wonder, is the mission over? Are our men in danger? They had seconds to decide. Abort the landing and leave, or trust a computer with only 72 kilobytes of memory, less than a single photograph on your phone. The call comes through from Jack Garman, a 26-year-old computer expert. "We're go on that alarm." But he wasn't guessing. He knew something about that code that would save the mission. To understand the alarm, we have to understand the brain of the ship, the Apollo Guidance Computer. It was called the AGC, and it was the most complex machine ever flown in space. It didn't have a hard drive or flash storage. It had something remarkable. Core rope memory, software literally woven by hand into physical hardware, one wire at a time. These were the programmers, skilled women, many of them nicknamed the little old ladies, who wove software into hardware with nothing but needles and patience. If a wire passed through a core, it was a 1. If it looped around the outside, it was a 0. At a time when computers filled entire buildings and required teams of technicians, this device, smaller than a modern microwave, had to be reliable enough to land on the moon. Your modern toaster has more computing power. Your smartwatch is 1,000,000 times more powerful. Yet this machine, with the memory of a single photo, had to navigate through the stars. Astronauts didn't use a mouse or touch a screen. They communicated with the machine in its own language, verb and noun codes. Verb 37, noun 00, meant proceed to the next step. Every command was a conversation. The software was led by a 33-year-old mathematician named Margaret Hamilton. She saw something others in the industry didn't. Computers make mistakes, and engineers must plan for failure. Margaret Hamilton designed something revolutionary: priority scheduling. If the computer got overloaded with too many tasks, it was programmed to drop the unimportant work automatically and focus 100% on the one task that mattered: landing the ship safely. During the descent, a radar switch was accidentally left in the on position. It began flooding the computer with thousands of unnecessary data points per second. The AGC wasn't designed to handle this overload. 1202 meant something specific in the computer's code: executive overflow. I am drowning in data, but I am still alive and working. It was a warning, not a death sentence. It was the computer crying out for help, not surrendering. Neil Armstrong's hand hovered over the abort button. One press, and they would jettison the lunar module, fire the ascent engine, and return to orbit. But he made a choice: trust the machine. The machine was doing everything right, clearing its own memory, maintaining control, compensating for the junk data. But the last crucial decision belonged to the human: find a safe place to land and do it in the next 90 seconds. At the last possible second, with only 25 seconds of fuel remaining, they find a clear, flat spot. "Houston, Tranquility Base here. The Eagle has landed." The 1202 alarm was forgotten instantly in the joy. But every person in that room understood something profound. Without the priority scheduling algorithm that Margaret Hamilton designed, that program would have crashed mid-descent, and they would have crashed with it. That moment on the moon changed how engineers write code forever. Programmers learned that software must be resilient. It must not just fail safely, but actively recover and adapt when unexpected things happen. From the moon to Mars, every autonomous spacecraft, rover, and system uses the fault-tolerant, priority-based logic that was born in that tiny 1960s box. Hamilton's principle is alive in every AI and autonomous system we build today. The 1202 alarm wasn't a glitch. It was the moment tech history was written. It was the moment humans decided to trust machines, and machines proved worthy of that trust. Thanks for watching, and thanks for caring about the stories that changed our world.